In this video, we are going to design a 4-bit adder. For that, go to File, New Project, click on Next, click Next, RTL project, click Next, board as Basis 3 board, then give Finish. Then go to Design Source, create a design source, create a file. First, you have to create a full adder program. Give OK, Finish. And I have already the program for full adder. So if you see, there's a program for full adder, module name, sum carry is my output, ABC is my input. So I'm going to use data for modeling. So sum values A XR B XR C, and the carry is A B plus BC plus CA. So you save this project. So FE is the name of the project. Then you run the simulation, run the synthesis. So you can see it is running. So you know the circuit diagram for full adder, right? This um, circuit diagram for full adder. So sum is equal to A XOR B XOR C, and the carry is equal to AB plus BC plus CA. So it is synthesis completed successfully. Okay, now I'm going to design a 4-bit adder. For that one, you again click adder, create a design source, create file. It's a 4-bit adder. So 4 adder, I'm giving the name as 4 adder. Okay, so already having the program. So this is a program for 4-bit adder. I go to the 4-bit adder program, paste it here. So let us see the block diagram of the 4-bit adder. So you have a 4 full adder. So I'm going to add these 3 bits. Okay, A, B, A0, B0 and Cin. So if I add, I will get the sum and carry. The carry values here I have represent as C of 0. That is a wire. It is an interconnection. Okay, and I'm going to add A1, B1 and C0. I will get sum and carry, that is C of 1. And if I add A2, B2 and C of 1, I will get the sum as 2, sum 2, and the C of 3 is my carry. And if I add C of 2 is my carry. If I add A3, B3 and C of 2, I will get sum of 3 and carry. So this is my circuit. So I'm going to implement this using a Verilog program. So you have you can see CAR is my output carry. Okay, so in the diagram I have represent as CARRY. So I'm going to change this one as CARRY, and output is so how many outputs are there? If you see the diagram, I'm having 5 outputs. Okay, 5 outputs, and I have nearly 9 inputs. Okay, So output carry S0, S1, S2. There is sum of 1, sum of 2, sum of 3, and so these are my four outputs of sum, and A0, A1, A2, A3, and B0, B1, B2, B3 are my input, and C in also my input. So the wire is the interconnection between the two full adders. So I have C0, C1, C2, and C3. So in the I'm going to map it with the full adder. So in the full adder, you can see it start with some carry A, B, C. So and the name of the full adder is FA. So I'm having four full adders. So I'm using four FAs. FA name of the first full adder is M1. So S0 is the sum of the first full adder, and C0 is the carry of the first full adder, A0, B0, and C. So you can see you have sum of 0 and carrier C of 0 and A, B, C, Cn. For the next full adder, that is named as M2. It is sum of 1. Here it is S1, C of 1, A1, B1. A1, B1 and C0. So you can see the program. S1, C of 1, A1, B1 and C of 0. Likewise for the third full adder, that is named as M3. Sum of 2, that is S2, C of 2, A2, B2 and C of 1, right? Sum of 2, C of 1, A2, B2 and C of 0. For the third full adder, that is M of 3, sum of 3, here it is S3, carry A3, B3 and C of 2. Right, S3, carry A3, B3 and C of 2. So save this project. Okay, so now this becomes a top module. So you can see, so now it becomes a top module. So if it is a top module, you will get the symbol like this. Okay, so again you synthesis this project. So now it is running. So since this is completed successfully, you click run. So now it is showing open implemented design. You click on OK. Then go to IO ports, scalar ports. In the scalar ports, you select it as 3.3 volt. Okay. Then give my input A0 is nothing but W2 and A1 is U1. Then A2 is T1 and A3 is R2. Then for B0, you give this V2, T2, T3, T2, and this is R3. Then scene, you can give it as W13. That must be always, sorry, W13. It must be always 0. Okay, scene must be always 0. Then carry out. Carry out, they can give it as L1. And sum 3 is P1. P1 and sum2 is N3 and it is P3. Okay, so you save this constraint file. To write the test bench, you go to source. Okay, click on this one, create simulation source. Okay, 4-bit adder test is the name of the simulation source. I have already having the program. So in the delete this one, go to test bench program. So here there's a program for test bench. Okay, I'm just copying this one and I'm going to paste it here. Okay, so change the program name as, what is the program name? 4 adder. And here I have changed this one to carry, right? So here this is a program for the test bench of the full ladder. So given a module name A0 to A3 is my input, so I have given it as register. B0 to B3 is also input, C also input, so I have given it as register, and output I have given it as wire. So 4 adder is name of the 4-bit adder. So this 4-bit adder name is UT. So you start with the carry S0, S1, S2, S3, A0, A1, A2, A3, B0, B1, B2, B3 and Cin. So I have written it as carries S0, S1, S2, S3, A0, A1, A2, A3, B0, B1, B2, B3 and Cin. So here the carry is nothing but CAR. So I have written it as CAR, CS0, S1, S2 and all the names are same. So initial, begin, you start with I'm giving the name for, I'm giving the values for the inputs. Okay, so A0 to Cin is my total 9 values. So I'm giving either 0 or 1. So after 10 nanosecond, I'm giving the values for A0 to Cin. Okay, so I have given nearly 1, 2, 3, 4 values. Okay, so you save this project. So here I have to give the output as carry. Okay, so there's a problem. You save this project, again you run the simulation. So if I run the simulation, so you can see for all the values are 0, sum and carry is 0. If it is, what is this one? 8 plus 4 plus 1 is 13. 13 plus 13. 13 plus 13 plus 11 is 24. So if it is 24 means it is 16 plus 8 is 24. And here also you can check the value. So you are getting the correct answer. Okay. So now let us click the go to the source constraint file. You click generate bit stream. Initializing the design. So the right bit stream is completed. You click on the open hardware manager. Okay, open target, program device, 4-bit adder. Okay. Initially, all my inputs are 0, 0 can see, right? So these are my A0, B0 and C in. So I'm going to make the B0 value as 1. So if B0 value is 1, sum of 0 is 1, right? If B of 1 is 1, sum of 1 is 1. B of 2 is 1, sum of 2 is 1. And B of 3 is 1 means sum of 3 is. So that is if A0 of 1 is 1, so you will get answer as 9. If it is A2 of A of 1 is 1, you will get this answer. A of 2 is 1, you will get this answer, right? So if A of 3 is 1, so 8 plus 8 is 16, so the carry pin is 1. If 9 plus 8, you will get answer as 16 plus 1 is 17. So the carry pin also is 1, so sum of 0 pin also, that is 1.